what I'm going to do in this talk is give an overview of etcd 05. etcd 05 is the next major release of etcd. We've been doing a lot of fairly major improvements internally on etcd, and I gave a similar talk to this about 4 weeks ago with 0 demos, and in this talk it will be filled with demos. So wish me luck. So this is an interactive presentation, so if you have questions, ask me. If you're going to heckle, don't even think about it. And all right, let's get started. So the first piece that we sort of have changed in etcd is basic configuration. One of the things that we found while people were using etcd and configuring it was that they would run into mistakes and problems. As developers, we figured that we could probably be doing a better job, and so in this release, we are doing a better job. The first piece that a lot of people would run into problems with is just getting their cluster bootstrapped and started. And so before, what etcd would do is we would kind of bind the cluster together. So people would just join the cluster, and then we'd allow them to join. So you'd start with one node, and then a second node would join, and then a third node would join, and so on. The problem is that etcd requires a quorum of machines to be up. So this means that at any given time, if you have, say, a 2-node cluster, so you started with 1, and then you go to 2 nodes, and then that node that just joined goes away and dies, now your cluster is never able to make another configuration change. So very early on in the cluster's lifecycle, you could make a configuration mistake, like starting the first node, starting the second, stopping it, and now you can't join a third machine. So what we decided to do is make it so that the initial bootstrap of the cluster is completely static. So in etcd 05, if you want to just configure, say, a 3-machine cluster, a 3-member cluster, on each of the members, you say, these are the 3 people that are going to be in the cluster initially. And this is running on my laptop, so all the hosts are local hosts, but they have separate ports. And so I'm actually running a 3-member cluster, and it has these all configured in this proc file here. So they came up with this static configuration. They found each other, and they started working. So that was the first major piece of configuration change that happened. The next piece was that we also made it very explicit when you're adding and removing members to the cluster. So we added a subcommand to etcd. I'll show you here in a second. So we have an etcd etcd-ctl members subcommand from my source code directory. Oh no, what have I done? Just member, says the guy in the back. OK, there's a subcommand now called member where you can list, add, and remove members from the cluster. Hooray! Yay! So I can explicitly now, make cluster configuration changes, and so, well, let's just add one. So I'll go through and I'll add a new member to this cluster called info4. It prints out, it says it added that member, and then it prints out some configuration information. Since this is a live demo and I'm not trusting myself to copy and paste things, I already configured a little script that takes those configurations and launches an etcd with it. So I should be able to start this guy, and hooray, he joins the cluster. And we can also list and see that that guy actually made it into the cluster now. So we did kind of a static reconfiguration of the cluster, and after the cluster acknowledged the configuration change, we were able to launch the new machine. OK. So hooray, says that guy. All right. The next piece is, along with configuration, is that we found that we trusted the user. So we trusted the user to create unique names. We trusted the user. Sorry, everybody. We don't trust you. We trusted the user to create unique names, unique cluster-wide names. So if you spin up 4 members in the cluster, you want to have, each of them should have a unique name, such as 1, 2, 3, 4. It turns out that this can lead to a lot of mistakes because the common unique name would be a host name. And it turns out that in a lot of cases, the host name may not be so unique, like localhost. So you have localhost talking to localhost, and then localhost joins, and he's like, hey, I'm localhost. He's like, whoa, I'm localhost too, that's great. And things get very confusing very quickly. So what we've done is, inside of etcd, we give each member at initial start a unique and random or generated number. So in the case of this cluster that we were talking about here, let's make it less noisy. So each of these members have a unique cluster identifier, and that is through the life cycle of the member. And we also keep around like a cluster deletion list. So if I remove one of these, say the guy that just joined, see infra 4. So we remove him from the cluster. Oh man, where was he? He'll actually stop operating, and he'll say, I was removed. You need to take action. He's actually permanently removed from the cluster, and that ID is permanently retired from being used again. It's an int64, the ID, so we have a lot of numbers to remove from the cluster, so don't worry about running out. But that's the first internal ID. The second internal ID is, we have this, shoot, you can't see. We have this number here, which is a unique cluster identifier. What we also found was that people would sometimes bridge a cluster. So they'd have 3 members here, and then they'd accidentally add a member here, and then he'd be halvesies in this other cluster. And so we can actually reject people. So we say, sorry, this unique cluster identifier, we don't recognize it. Please go away and stop talking to us. So it kind of helps keep configuration mistakes from breaking etcd and protecting the user from accidents. All right. So along with adding internal IDs and these configuration safeties, we've also done a pretty major change in our Raft implementation. And we have teased out a lot of the major components of a Raft implementation. So we have a very core state machine that you kind of step through the state, and you have a main event loop that pushes events, including time, through the state machine. And then you work through and figure out which things were accepted by the state machine and which things you need to persist to disk. And so we've kind of teased out the idea of the state machine from the actual storage, the WAL file. And it's a nice, clean, like around 700 lines of code implementation of the Raft state machine. And the nice thing is we actually pulled time out of the state machine, out of our implementation, so we can test the thing really fast. I think all the tests now for our Raft, the Raft core is passing in a couple of seconds on an average laptop, where before we were using timeouts and wall time, and it was taking on the order of minutes. The team's done a nice job there. In our Raft implementation, we've been working, Xiang, one of the core etcd developers, has been working with another open source project who's been using our Raft implementation to do a multi-Raft. Some other people have started to adopt it, which is great. The next piece is we, along with users finding interesting corner cases, our log file used to not have internal checksums. And so we've added in our WAL file a CRC for the entries. And it's a rolling CRC of the entire file. The nice thing about this is that we can protect ourselves from random problems that may occur and kind of protect the etcd from, we've been using protobufs, and so it's a little tricky when there's a bit flip or if somebody truncates a file in a very particular way to detect that without checksums. So we now do checksums throughout the WAL file. This is a big and very useful change. Is etcd can now listen on lots of ports. So if you can connect to any of etcd's ports, whether you're behind, say, a bridge for your container network, etcd will take care of proxying that request off to the leader. So this means that you never have to be aware of the network that etcd is running on, and you never get a 307 redirect. So etcd used to give you, say, a 307 every time you made a request to a machine that wasn't the leader. And so now, if you make a request and you're able to successfully connect to etcd, etcd itself will take care of proxying that request to whoever the leader is and getting you the response of whether your change or your read was successful or not. Which is really nice because this means we can attach a port, say, on a Docker bridge, and the Docker bridge doesn't have to be aware of the internal network that the actual host is running on. So it leads to a lot of really nice side effects. In the future, we will, say, listen on a Unix domain socket too, and be able to proxy that request off behind the user's back, which is really helpful. Along with proxying, confusingly, we added proxies, which is a feature where there's a little library that we have in etcd that other people can consume that makes it really easy to write a new proxy. So a proxy sits in front of etcd, and you can, just like a regular HTTP reverse proxy, but it has special logic to keep track of the changes happening in the etcd cluster. And so in like 60, 100 lines of code, I wrote a little proxy that gives you read-only access to certain sets of the keys and read-write access to the other sets of keys. And so we'd like to start to see more people kind of experiment with changes and interesting features that we could build on top of etcd with this proxy feature, such as having an access control proxy like I've built, where it's a read-only proxy for certain subsets of the key store. Along with all this, we've significantly reduced the amount of time that tests take in etcd, mostly because we were able to remove this time component from our Raft implementation. So let's go ahead and do a live demo of testing. So this is the test script running on my laptop, which isn't the fastest machine in the world, but it's going through and testing all the pieces of etcd and our Raft implementation, although it hasn't hit there yet. So the Raft implementation is sitting around 2 seconds for a full test, and the coverage is pretty good at 91%. All right, so you've been a very quiet crowd, but I'm happy to answer questions about this release. etcd 0.5 alphas are up on GitHub. There's Docker containers. There are builds for OS X, Windows, and Linux. The Windows builds are completely untested, so please test them. And I love cross-compiling in Go. I can make binaries for all sorts of things that I can't run. And please give it a shot, because we've made a lot of changes, and we think that they're really solid and make big improvements to the overall operationability of etcd. So thank you, and I'll take questions. Yeah.
You're still supporting the etcd.io way of bringing up your etcd?
Oh yeah, sorry, I should have mentioned that. So the discovery etcd.io process, where you bootstrap an etcd with another etcd, that still works. The tweak that we've made from etcd 0.4 to 0.5 is you have to say what cluster size you expect, and this is to avoid that, like, 2 of the machines come up and then one of them dies problem, which we see sadly fairly often. And so you say, like, I want it to be 3 or 5. And you can do that today on the etcd service. On the new /new API endpoint, you can pass it a size parameter. And that's just a key. It's like config/size or something that we read when we start the etcd cluster. So yeah, discovery is fully supported. You can do it without knowing all the IPs ahead of time. The plant.
Let's turn the screws. So when can we expect to see etcd 0.5 in the alpha CoreOS image?
Okay, that's a good question. So we've been making weekly releases on alpha, or weekly releases of etcd alpha, and I think in the next few weeks we'll be able to push it in. There's a lot of like features that we've been polishing off, and also we want to make sure that the V2 API supports really solid. We have tested against Fleet and Locksmith, but we want to make sure that all of our existing applications work well.
You were talking about the new proxy feature and how you were, you have an app that's limiting the scope of the access for the NCT for the key store?
Yeah.
Can you just go into that a little bit more? I couldn't quite get my head around it.
Sure, yeah. So there's two features. We proxy requests now, which means that when you contact one of the etcd endpoints, it will directly give you a response back. In the past, we had, when you contact the etcd, it may give you a 307 and say you need to go here to fulfill your request. The other piece is that we have a Go package within etcd called Proxy, and this is a tool that you can use to implement your own proxy on top of etcd. So a reverse proxy that keeps track of the etcd cluster state. So it knows who the members of etcd are, and you can write your own application on top of this and kind of write your own, like protect the key store or require access control or like check an API token. Say you want to make sure that anyone who docks to etcd has some sort of API token that's specific to your environment.
Crypto?
Yeah, it's just an arbitrary HTTP reverse proxy, but it keeps track of the etcd cluster, so it knows who to send the authenticated request off to. Does it make sense? Yeah. Okay. The package documentation probably is more helpful. It's in the /proxy folder.
Hi. I just want to ask a little bit about how you've tested some of the scalability. Brian told us a little bit about looking towards federated clusters with etcd at a recent meetup. So I was wondering if you could tell us a little bit about testing the scalability of etcd.
Sure. So in any consensus system, you want the scale of the cluster to be small. So the number of actual participants in the consensus is around 5 to 7 generally. But on the read-write scalability, there's a few different options that you have. So one of the things that we are shooting for is to be able to support really good read scale out. And the way you do that is you replicate the Raft log off to machines that aren't part of that 5-machine quorum. And so in the release after this, we're going to start having that feature where you can say, I'm an etcd member, but I want to be a read-only member. So just give me a copy of the log whenever the leader accepts new changes, and I'll be able to service any read-only request. And I have a full copy of the log. I'm able to do watches. I'm able to fulfill any GET request of etcd. The other scaling things around etcd is improving our Raft implementation internally so that we can, we've been writing up how we're going to do a streaming Raft implementation so that we can have more of the commands stream through instead of being more of a request response. So we can stream a number of append entries requests at once. I know Xiang and Yi-Chen have been working on that in the last little bit of time. So. Does that fully answer? That helps. Oh, okay, cool.
Thank you. I'm pretty newbie in etcd, and I'm planning to use either etcd or console for service discovery. Sure. But I have the same problem. What about integration with the application, the existing application, communicate using variables, give the developers the full API so you can curl to the or use memcache. How is what's a good practice for integrating with existing applications in a high performance environment?
Sure. So there are a few different things you can do. There's a number of applications built on top of etcd to help you out. So there's a project called confd, which can help you take a set of etcd keys and serialize those out to, say, an Nginx configuration. There's a thing that will serialize out to environment variables. You can also do things. There's a project called SkyDNS that takes an etcd key store and turns that into a DNS server. So if you need to, say, serve records or A records of some sort, you can take those and service them into DNS records. So it sort of depends on what your application is looking for and what you're trying to do. But there are, if you look through, there's a number of applications that we have in our documentation that might be helpful. And I'm happy to kind of talk offline too. Yeah. All right, thanks guys.